No problem.
Okay.
Jacob?
Yeah. Saif, can you speak up?
Hi, Srini. Can you hear me?
Yeah,
Okay, perfect. All right.
done. Thank you. So we will continue.
There is an echo, I believe.
No, from my side. I mean,
Srini, you can hear me very clearly?
yes.
Okay.
Good. Mandar is also online. I saw him. Mandar?
Yes,
Mandar, are you there?
yes,
I can hear him very feebly. I think he's there.
So just note that when Saif is talking, it is going to appear as Shekhar Dongre talking. So Srini, you might need to make sure that you brief people. I'm going to go on mute now.
Saeed?
Yeah.
Okay. So even though Shekhar is mute, you will be able to talk. That's good.
Yeah, maybe you'll have to say that I and Shekhar have logged in together.
That's correct.
But you can hear me very clearly, is it?
Yes.
Even I don't have any echo or anything.
Good, good. So let us wait. Now it is 11:30 our time. So we will wait for some time and then.
You have to realize that I am going blind here, okay? I don't have that screen where I can see people logged in or even your presentation for that matter.
Correct, correct. But that is the reason I run through you before the webinar. So
Yes.
you.
So maybe if you could just say, okay, we'll move on to the next slide, moving on to next
Correct.
slide. I'll keep moving on from here as well.
Correct, correct, correct. That's correct.
Okay, make sure that next time, oh, are we online? Okay. Mandar or Jitendra to get my laptop.
Yeah.
Aisha, नहीं बेटा.
Hi everybody, good morning. Uh, Thanks for joining the webinar on efficiently scaling out large web applications with Azure and ARR. So I just want to quickly brief on the agenda today, what we will be covering on this webinar. So we will try to understand what are the scalability options available in Azure, what is ARR and how it helps in scalability. And then we will understand how Azure can be leveraged the ARR concept and achieve the optimized scalability for the solutions, and then what are the benefits this approach offers. So further to this, I just want to take a couple of minutes to introduce myself and my colleague. Myself, I am Srinivas Pillai. I am leading Azure and mobile practices at Spadeworks. I'm handling the solutions conceptualization as well as pre-sales and delivery of Azure and mobile solutions at Spadeworks. Now I will request my colleague Saeed to introduce himself. Saeed?
Hello everybody. Yeah, thanks Srini. Hello everybody. Myself Saif Manlik. I'm Azure architect in Spadeworks. Basically responsible for designing and architecting solutions to our various clients using the different Azure technologies, implementing it to the best of its use.
Thanks, Saif. So now let us start on the webinar content. So I'm taking through quickly on Azure and the scalability it offers. Before touching the scalability, I just want to introduce a quick snapshot on Azure. What is Windows Azure? It is a beaten word now, though all of us are well aware on Azure as a technology platform launched by Microsoft a few years ago, but now it is getting the momentum in the market, and a lot of enterprises are giving serious listening to this Azure. Though Amazon is there in the market, however, Azure is started giving some competition to other cloud vendors. Now, Azure as such offers different execution models. What are they? Azure offers virtual machines on which you can host not only Windows operating system based virtual machines, but even other operating systems also it started supporting. And for lightweight consumption, Windows Azure also supports websites that can be hosted on the Azure instances. And the key thing which was launched earlier in Azure portfolio was cloud services. That includes compute instances, that includes storage, etc. And last but not least, which is hot in the market, is mobile services. So these are all the various execution models that Azure offers today. And going to each and every bucket, for data management, SQL database, which is an Azure instances of SQL server, that is one of the service. But not only SQL in Azure environment, but Windows Azure also offers tables and blobs as a data management options to the users. Then tables and blobs, these are non-hierarchical, non-relational data stores. So tables can be used in similar to big data concept. However, blobs are to store images, videos, etc. Binary large objects. Then Windows Azure also offers different networking options like virtual networks or traffic manager to wire different instances that are hosted in Windows Azure. The key important part that is coming out most powerful in Windows Azure nowadays is the HD Insight and SQL reporting. The HD Insight is where the big data is coming and the support is being built into Azure. Another critical component in Windows Azure from ground up since the beginning is the messaging infrastructure. From messaging infrastructure perspective, Azure offers both a service bus based messaging as well as queue based messaging. Service based messaging further offers approaches where it can provide publisher subscriber model and based on topics. So that is very powerful, where we can have a one topic which can be subscribed by multiple channels. So this type of a infrastructure is being offered by Windows Azure. The content distribution network CDN and caching will help in achieving massive scale where media related solutions can leverage this capability of Azure but can stream large volumes of data across the world. Other key thing that came into Azure recently was Windows Azure Active Directory. Due to this, the AD federation or integration with on-site and on-premises and Azure-based solutions can be done in an easier manner. The media services offers the video rendering and streaming capabilities built into Azure. Using this, we can develop powerful solutions for media segment. Recent additions to Azure from a commerce perspective, which are becoming powerful day by day, are the store and marketplace. Marketplace is where we can submit Azure-based solutions where other partners, customers can purchase, like app stores. The big compute, which is the hot topic these days, is another key segment in Azure, which is HPC scheduler, high performance computing scheduler, that is also built in top of Azure nowadays. Now, Azure, though it is from Microsoft, but Microsoft is addressing various technologies and provides SDKs to build solutions on not only .NET but onto Java, PHP, Python, and Ruby. Of course, Node.js, which is picking up a lot of momentum in the market, is also being supported on Windows Azure. So, in summary, Windows Azure not only caters only to the .NET technology area, but it caters to other technologies with a bucket of capabilities, features, using which we can build a lot of complex and solutions which require massive scale of infrastructure easily. Going to the next slide. What is scalability? What type of options that Azure provides to meet scalability for large solutions? Now, today Azure provides the load balancing, and Azure also have the capability to launch instances based on the load that is being carried out to a specific instance. So here in this diagram, we are seeing a lot of users are trying to access a portal, blogs or forums, which is hosted in one instance. And based on certain configurations, Azure itself can spawn new instance so that the other users who are trying to access the web application can be redirected to the second instance. So that type of a capability is already built into Azure. In summary, the management portal of Azure provides certain rules on which we can configure additional instance creations. So for example, if CPU utilization reaches 70% of the threshold, then launch a new instance. So we can set such type of rules where the new instances can be instantiated based on those criteria. Now, based on this criteria, Azure itself spawns new instances and the application will be load balanced. So the workload can be distributed among all the instances that have been launched by Azure. However, there are few shortfalls in the way that Azure manages the scalability. If we see carefully, this type of a mechanism doesn't help in proper resource utilization per application. What does it mean? If we see the web application, it has three components. Whatever the application that we talked about, it has three components. It has a portal, it has blogs, it has forums. Now all these three are a part of a web application which are hosted on a single instance. However, the way the Azure is spawning new instances will replicate the complete web application on a second instance. Due to this, even though the web portal has lot of hits, whereas the blogs and forums does not have many hits, still they are occupying the same amount of CPU and compute times. There is no optimization is happening on the resource allocation per module. So that is one of the shortfall. The other one is to achieve a lot of scale to address the portal related hits. What may happen is we may need to end up in spawning more and more instances because the CPU utilization may be reaching 70% because a lot of hits are happening onto the portal component. Due to this, many instances will be launched, which results in higher costs. Comes to ARR. What is ARR? ARR as application request routing, which is a Microsoft module in iOS 7. Now, ARR helps in routing the requests to different servers that are part of the infrastructure. And ARR also helps in formulating the rules based on HTTP headers or based on the URL format. So ARR has this capability in routing the requests according to the URL or based on certain HTTP header values. This helps us in achieving higher scalability or load balancing. So for example, as you see in this diagram, on the left hand side, the tier 1, the server in the tier 1 section is a ARR server, a server that is hosting ARR component. So whenever there is a request comes to that server detects based on the rules that are configured, it detects what type of resource request it is. If it is for a specific type of request like a web content, it forwards that request to the server in tier 2, which internally accesses the database and it returns the response back to the ARR server, which ultimately sends the response to the client. So based on certain rules like the content type or the URL or the metadata in the HTTP headers, the request will be routed to corresponding servers. The other diagram that is being shown in this graphic is the servers at ARR level to be load balanced, because ARR itself does not give the load balancing capability. ARR is only to route the requests based on certain rules, but this approach will help us in realizing the full potential or load balancing based on the type of requests that are coming out. So, however, this approach also has few shortcomings. What are those? So ARR, since it is a rule-based mechanism, it does not have a capability to launch new instances on its own. It only can redirect the requests to specific servers, but it cannot launch new instances on its own. The other key shortfall with ARR is scalability is limited based on the size of the type of the server on which ARR module is installed. If the ARR module is installed on a small server, based on that, its performance, its scalability, its fault tolerance, everything will be impacted. So these are the typical shortcomings on using ARR in the solutions. Now let us see if we start integrating, leveraging both ARR coupled with Azure, how it really helps in achieving a higher scalability. So here is how the overall scheme of things will be there. Now what happens? Earlier from the network load balancer, the requests are being directly hitting the instances. However, here the requests are being forwarded to the ARR instances. So the ARR module has been installed on a couple of instances. So this way we are handling the fault tolerance of ARR modules itself. Then ARR module itself forwards the requests based on the type of requests that are coming from users. So if the request is for certain content type or certain URLs, the ARR module will detect and forwards it to the respective instances. So here the portal, which is a actively being used by users, is having two instances, whereas the blogs and forums application are running on a single instance. This way, the Azure can spawn more instances for portal based on the load that will be taken care by Azure, and the ARR will take care by forwarding the requests to respective instances, thus optimizing the overall load across the instances. Is this offering any benefits? Yes. How? The fine-grained hardware resource allocation. What does it mean? We are able to control the application scalability by fine-tuning the control at the hardware instances level. This will help us in controlling the billing cost from an Azure angle. So we will not be able to pay a lot of price for the hardware instances. However, because we are spawning only the instances for respective application modules, we will be able to control those billing. The other key thing that comes out due to this is we can be able to develop and deploy different modules because this complete solution is loosely coupled. So I can deploy a new module easily on a new instance, and the ARR rule automatically can forward the request to that role. And though SEO is not a key thing from a business angle for business solutions, however, that will be more useful in case of public facing internet portals. So the SEO will also be synchronously, seamlessly maintained due to the ARR and Azure combination. And last but not least, whenever a new module or new feature comes, we can easily add it to the overall solution without disturbing the existing setup, because this way the ARR rule just detects the new server and it redirects the request to that new module easily. So thus it provides extensibility to the overall solution in a much elegant fashion. So where we can use this ARR with Azure? We typically listed down a couple of scenarios. However, we also feel there are many scenarios that this combination can be practiced. So the key thing is, when there is a large web portal like Yahoo or MSN or such portals where we have a lot of modules it could be as the example we are talking about. It could be the forums, blogs, and other news items, videos. So each module can be developed as a separate entity, and web the web initial module can be as a separate application. And based on the routing requests, the ARR can forward the request to respective instances, and those instances can scale up or down based on the load. So this will give better performance of the overall web portal as well as fine-grained control on the overall instances sizes. Other scenario that we have identified is where a multi-tenant SaaS solution. So if we envisage a typical ERP type of a solution where procurement, logistics, sales and distribution, etc. So each such module can be treated as a different application and can be hosted on their own instances. And based on the request, the routing will takes place from the respective instances. So this is another scenario where we feel the ARR with Azure will help in achieving higher scalability, but with an optimized cost. So today ARR is already being implemented with Azure in a CodePlex library which is called Cloud Samurai, that is available in CodePlex. So that already has this as a case study. We can check that out. The other one is people started looking at this mechanism where we have given example URLs in this screen. So different departments started using the redirection, but with individual sub-applications. This is being practiced in one of the big SaaS vendor that we are aware of. We cannot disclose the name because of various reasons, but this is started being used. So this is what it is, and now I will hand over to my colleague Saif to demonstrate the ARR with a sample.
Me?
Saif, over to you.
Yes. Thanks a lot, Srini. Can you guys see the screen? I have a IE browser open with
just give me a minute.
Yes, please. Yeah. Yes. Are you able to see it?
Yeah.
Okay, great. So essentially, I have tried here to replicate the same scenario which Srini presented in his slides, being a portal site wherein you have a home, about us, contact, blog, and forum. So this, take it for granted that this is your huge or big internet application or an internet-based website wherein you have different, modules inside it, blog being a separate module, forum being a separate module, and that kind of stuff. So if you could see here, what I've done is this is a plain MVC4 internet application template-based web app that I have created. And in that I have added a couple of more pages or views to it about blogs and forums. Nothing great so far, right? But there's one little special thing here. If you could look into it, I have deployed this application into Azure, okay, into Azure Cloud. This is a web role. And what I've done is for every view that is rendered, I'm actually printing out the web role as well as its instance, basically the instance ID that is of the server that is actually processing the request, right? So no big deal. Home is getting processed by a web role. Obviously, I kept its name as Azure with ARR.web. I had deployed it with only one instance, so we are getting instance 0. The same would be with the about page, right? Over here, the contact page over here, and with the blog page. But wait, did I say the same would be here? However, it is not. This is actually signifying that this page is getting processed or rendered by a different web role altogether, right? So this web role instance ID is actually web 2 and the instance is again 1. Likewise, if I try to process forums page, even this is getting processed by a different web role. So essentially what I'm trying to demonstrate here is you have one application which is behaving like one application, right? However, the parts of the application are getting processed by different web roles. Here I'm not talking about different instances of the same web role, but I'm actually talking about different instances of the different web roles. And we have also incorporated single sign-on, so that if I log in, now here's that asset test. Here's what I'm claiming, right? I'm claiming that these three are from a different web role or from the same web role, and this two, that is blogs and forums, are rendered from a different web role. So how does the application or how they combine together to appear as the same application? Well, we have used single sign-on technique. So even if I log into any page which is being rendered by a different web role, as long as I'm using a federated, kind of authentication or a single sign-on authentication, it would still give you the impression, though the two modules are separately deployed. And the other way to...
The conference will automatically end in 5 minutes.
Sorry. So now let's show what exactly it is. What I have deployed here is, this is actually my solution, the Visual Studio solution that I have deployed onto the cloud, what you all will see. Here I have just one cloud project, right? And in that cloud project, I have deployed two web roles. This is my web, which is my main project, the portal project, which was rendering the home, contact, about us, the login, and that kind of stuff. And web 2 is actually the project which is rendering the forums and the blogs. And just to show you, demonstrate that that's how it is, if you see the source code of web project, here I have just two controllers, the account controller and the home controller. There is no existence of forums or blogs here, whereas forums and blogs actually reside in a different web role altogether, right? So in short, what we are saying is, don't build a huge web application with multiple modules in it, where your development team then struggles with each other, having dependency on each other. You deployed some other module breaks, and it breaks the whole source code. Just split your big web application into multiple web applications, and you can very easily present it as a one single large web application using ARR. Besides, since you are deploying each of your small modules as a different web role, you have more control over the scalability. Like in this example that I have presented, for me, suppose blogs and forums are not that much important, right? But it attracts more of my traffic. I want the performance of my other modules, which is say home, about us, contact, to be better. But because of blogs and forums is attracting more traffic, my performance of home, about us, and contact also gets, adversely affected because of that. If this all would have been in one single web application. However, since now we have deployed it in, two different web roles, I can actually dedicate more instances to my main portal and ensure that those modules which are more important to me get more resources and a better performance compared to other modules where I might not give so many instances but just maybe one. Maybe I don't care that it should be available if that one single web role is down. I'm fine if the blogs is not available, if the forums is not available, that 5% of the time whenever that one single web role is down, but I'm saving my money. Whereas on the portal side, which I want, where I want 100% of the availability, I'll make sure I have a failover available, and hence I'll go ahead with 2 or more instances. So that is what we are trying to propose here, a architectural pattern or a deployment pattern, which apart from controlling the performance and controlling your billing, where you want to put your money into the modules which are more important to you, it also decouples your modules from each other, and the deployment task really becomes easy. I mean, think about this. There's some new functionality that you have added to blogs and forums. You develop it separately, you deploy it on a different web role, and your main portal does not get affected whatsoever, right? So if something messy happens, if blogs doesn't work, if your forums doesn't work, it still doesn't matter. Your home page, your about us, your contact will always be available because it is not touched. Likewise, your extensibility increases. I think all that Srini has anyways covered in his presentation. Here what I'd quickly like to cover is how we have achieved it. What over here I have done is ARR actually stands for Application Request Routing. It's a module which is not by default available in IIS, but you have to install it separately. And once your ARR is available, then you can use it coupled with your URL rerouting to further route the request to the different module or the application servers that we are talking about. So in this example, in my main web, which is rendering my home page, my contact, and my about page, in that page itself, I have deployed ARR, and in the web config, I have configured the different rules that would decide for which request the the request has to be forwarded to the web 2 server. So here is the rule. Basically what I have done is first I have written a rewrite map. This is something like a lookup table which has a key and a corresponding value to it, right? And then in the rule, which is this first inbound rule, what I'm seeing is I'm seeing whether the request URL starts with either blog or forum. And if it does start with either blog or forum, then I'm passing this value on to this lookup table to get the value, which is the actual application server name. And I forward the request. If the condition is satisfied, the action happens, which is actually a rewrite, which means that the incoming request of the user is forwarded to this URL which I have mentioned. And what is this URL? This URL is specifying that which is the server which is actually which would actually process a blog request or a forum request. So that's how, it uses regular expressions. You can use different parameters on the rules, on the conditions, and build your different inbound rules. It also supports outbound rules. This is very brief about it. There's a lot of documentation and stuff available on Microsoft sites, but what we wanted to demonstrate here is how you can actually, maybe discourage your developers to develop a big web application with 1,000 or maybe tens of modules. Instead, split it into multiple web applications and deploy it so that you can better control its, its scalability, the number of instances that you want to dedicate per module and kind of stuff. That's it from me.
Thanks, Ayush. We are almost at the end of the webinar because we have 5 more minutes. Let us open for any questions from the audience.
Okay.
Yeah, looks like there are no more questions from the audience. So thanks, Saeed. Thanks for coming on board. Thanks to all of you who participated in this webinar. So we will continue the series with more and more webinars in the coming days. So looking forward your participation in the subsequent webinars also. Thanks a lot. Have a nice day.
Thank you. Thank you. Bye-bye.